Okay, this is Sketchup, and given the following parameters, let's talk about some things, and we'll just see what the consensus is. So some of the parameters are 9 foot wide, 8 foot tall door, 24 foot by 24 foot slab. What's nice in SketchUp, see that? I can taper the floor. It's pretty cool. Stairs going upstairs on the inside. 2x4 wall construction. So let's just talk about this. That was about all I was getting. Oh, and 16-foot wide dormers front and back. That was the other thing. So right off the bat, if I was to put the stairs along the side, I would either have to offset the doors to the right, and we're already pretty minimal here, or when you pull your car in, you're going to have these stairs sticking out, and that'll be an issue. Something that also needs to be considered, because I don't know if it has been, is if this is ever going to be living space, then you have to come down the stairs and there'd be a door right here or right here. You cannot come down the stairs and then have to go through the garage to get out of the garage in case something in the garage is on fire. But we're going to turn that off for now because that's just extra stuff to think about. So in this scenario, for me, I would recommend 14-inch I-joists, the 560 series, the really heavy-duty ones, because they can easily clear span that, and there'd be no bounce. And then it takes 17 risers to get upstairs, and each one of these is 7 7/16, if I remember correctly. I measured from the tall point here. Actually, all of this sloped stuff, everything that's touching it is already flat, and then it's, as you can see, like right here, I sunk it into the solid. In real life, you would taper cut this to get this flat. Okay, and then so here's this black line is 6'8" headroom clearance. These are simulating 2x12 blocking in the wall for the handrail. So one of the problems that I had when given the instructions on, hey, let's make this garage, was 2x4. Yes, you can use 2x4, but along the stairwell, and I put it at the back for a reason, you'd have to balloon frame this. And I wouldn't balloon frame 18 feet with 2x4s. But with 2x6s, I would. So my recommendation is the entire back wall be a 2x6. I was going to explain something. You ever have that where you're about to explain something and then I was over here? Anyways, oh, that's what it was. I put the stairs at the back instead of along the side, and the reason I put them at the back was you can get these vehicles in there right now. So a subcompact SUV or something and a full-size truck will fit without the wall. If this is going to be living space or an ADU or some kind of Airbnb, then you're going to have to put in a wall all the way down, and it would all be fire rocked, and that truck won't fit. It'll bump into the wall here. I guess you could lid the bottom of the stairs and then run the wall on an angle so that the wall doesn't have to sit all the way onto the floor. And then you'd have a full-size garage. That's probably the better move right there. And use a lot of that rock wool, man. Insulate under the stairs just for noise before you put the lid on it. Just all kinds of neat stuff you can do. The portal frame here is not complete, but that's what this is. In Washington State, we have to run our headers all the way over to the outside with one king stud on the outside. And then you can look in the code book under portal frame, and that's how we do our big front walls, because there's nothing, this is mostly open. So that's what this is going to require, some kind of lateral resistance. I really hate using these straps, but it's easy in the software to just drop them in there. and I've got them pulled back a 1/2 inch so that the sheathing would be there, but I haven't added sheathing to this model. I'm more interested in the framing. So what I did was 12 and 12 front and back with a structural ridge going all the way down. And so this side, we'll just do some live stuff right here. M plus that way, M plus that way. So, and I think I would turn this around. I don't know why I did that. Kind of weird. I think I did it the other, yeah, see over there? Let's just do this. Let's, which way can I go to? Yeah, but I want to get everything. I made that an entire group. All right, so we're going to delete that. Come over here. Grab these three. Click, shift, click, click. And then I'm going to do flip plus. Grab the red one. Zoom into the middle. Boom. I wonder what that is. Huh. So what that did is it knows the building is 24 feet across is where that ridge is. So there you go, load bearing. And look at that. I've even got them taper cut. Nice. I know for a fact I did a 30-foot building and it had a 3.5 by 18. So I don't know, maybe this is a 15. I could make this an 18. I still think it would hide up in the ceiling. Yep. That's what these little collar ties are for. Just to flatten it out so you don't see that beam. But anyways, we're going back. So 12 and 12 this way. And then a 16-foot wide dormer front and back. I haven't put any windows in or anything. They take a little bit of time. On this side with the lay-on valleys, this is a lay-on option. What that gives you is a completely smooth ceiling all the way along. And these are 2x8s. You could spray foam that solid and get some pretty good R value. But with this system, then it becomes, let's go in here. Here's how you could get to this space. Whoa, whoa, whoa. Crazy. You can get to this attic space and actually use it. So there'd be lots of different options. You could put a band against the wall and joist across from the bottom of the header and it would just look like flat ceiling. Walk in and it's all flat in there. Or you could come across up higher if you wanted this to actually look like it was a header, or drop beam or whatever. And here's something. When you do a lay-on, a lot of guys will sheet the entire thing like in a truss roof, and then they'll come back and they'll do a lay-on like a 2x12 or whatever. Something wide enough that it supports each jack. See, this isn't wide enough. So you'd end up adding like a 2x4 or 2x6 to the backside of this so that it's fully supported. But we never did that when we stick framed. We always made all the framing work. And then we came back with blocking underneath. And then when we would sheet these things, it's a lot easier to sheet the entire roof and then put your lay on. But we liked making framing to framing contact. And then you would just bring your plywood over and this piece of plywood would run tight against here. And then as it came down here, it would go over that plywood, creating the valley out here to wherever this is. And then we would come up 2 inches for the subframing, the subfascia. Then you put on your 1/2 inch plywood and you got about 1.5 inch gap. But then your actual fascia board, depending on how thick the shingles were going to be, you came back like a 1/2 inch off of that so that no rain was making contact with that cut end. So that's these are 2x8s. That means this is either a 2x10 or it's a 2x10. That's what this is. And then these are 2x10s. The only reason I did 2x10s was like a 2x8. You can come in 11'7", and then you need support. And that's almost the span. I mean, it's not, but it almost is. And so I'd have to have purlin support somewhere. And I didn't really want to use these walls as load bearing. But a 2x10 all the way. So you don't need any mid-span support. But I put them in here anyways because on this side, this is a true valley. Here's a 6 and 12 tying into a 12 and 12. And that way, the only thing that's a pain about these is, let's see if I can get in here. In the model, I cut these flat, like they were sticking down, and so was the valley. It sticks down. So as you're sheetrocking, you would hit it. And a lot of times near the end of the job, when this is all ready to go, they would make us cut these back. And I'm pretty sure that's not structural, but we did it anyways. But you could do this with LVLs, and I know they'd be a lot stronger. And then you could actually get the ceiling to come across. It's either that, or you have to fur down these rafters to wherever the long point of this jack is to make the ceiling meet correctly. But as shown here, you would sheetrock across, and then this would come down. And if I was actually building this way, I would put blocking in between here at that change point, just to help the framer, the sheetrock guy, be able to get clean lines. And so, like, say you wanted a window in here, easy peasy. Hey, this doesn't have a block. What's going on? What is the deal? I'm gonna have to. There we go. You would put in a header, and then you would take this post load down each side, and then downstairs you would directly in line with that, you'd put blocking in the floor system, and then you would put studs all the way to foundation. And you would cut this out wherever you needed it, and you could get a nice big window in here. So windows are optional. They're easy to do. This is kind of more dramatic because you can walk along and your ceiling goes from a 6 and 12 to a 12 and 12. And you could put a nice big window here as opposed to, let's see, this one. Yeah, the ceiling's all the same pitch. It's all nice, but it's a whole different feel. So I'm looking at that as presenting options, which option, and some of this depends on how skilled the framing crew is, because every single framer is going to think they're the greatest that's ever walked the earth, because that's just what we do when we go to framing school. But if your expertise is in trusses, this will be confusing, because I'll tell you what, the first time I saw trusses, it was confusing looking on the plan because the truss lines were going the wrong direction for where I knew the rafters had to go, and they were stepping down, and I'd never seen that before. So I was like, well, how are you going to do this? But if you get a good framing crew, this isn't difficult at all. But like I said, like here, this is a full rake wall because it's just stronger and it's got blocking in between. And you will need to balloon this anytime you have a set of stairs that are touching any wall. You can't just come up and then run the plates and stick a next wall on top of it. That would be the wrong way to do that, because you create a hinge where the bottom plate of the upper wall sits on the top plates of the lower wall. And these just happen to be 18 foot 0.5. Check this out. Look at that, 18 feet and 1/2 inch. So in that instance, because I'd like to buy 18 footers, I'd probably add a plate. I'd make this wall a triple plate and lower it down so that from here to here, I mean, we can do that right now even. Let me think, what's the easiest way to do this? So there's a Medic plugin for this. I'm going to go M+. Come on, baby. Grab on there. Right there. So now I've got all these studs that are up inside here, and I don't want that. So Medique trim. See, there's what I was hoping it wouldn't do. Let's, oh, wait a second. Hey, this will work really good, actually. So what I'm doing is, there's a cutting surface that's green. It's made by Nathaniel Wilkerson. His company is Medique. He's a licensed structural engineer. And look at this. I can delete that. Go here, M+. So that's probably how I would build that wall. Just so I could get 18 footers and be able to cut a little bit off if they're split. We're going to mention this again and just see it should have taken off. It should be 1711. Look at that, 1711. Yeah, that's the downside of dimensioning in 3D in SketchUp, is it's not very clear. So what else can we talk about here? Ledger, spacing ledger. That one, oh, hang on, let's explode this so we can see the parts individually. Spacing ledger, 1.5 inches against framing. I've got one on both sides so that when we turn that wall on, and all that does is allow the guy who's doing the sheetrock to come down, and he just has to cut the stair angle and set his sheetrock down there. Because I've made the mistake when I was building my very first or second stairs, I just put the stringer straight to the wall. And the guy had to cut his sheetrock around all the treads, and they weren't too happy. So you learn. I would recommend they put a door right here, a man door. And I'm sure they're probably going to want one somewhere along. I don't know which way this is oriented on the ground. What else? What else? What else? And that's if you want vaulted ceilings. At any point, if they wanted, like this is 9-foot pre-cut studs on the downstairs on a 6-inch concrete stem wall. And this is 8 feet up here. So if you wanted just to run joists all the way across at 16 feet, you could do that. Have a flat ceiling up here. Or if they want to do scissors, they could do another drop beam across here and bring 2x6s up just to hold sheetrock. There's that option. You could get creative. You know, if you went with the side on the left, you could drop beams in here and build a big raised state of Texas or whatever. So, yep, there's that. I haven't finished out the overhangs. I think they're going to be like 16 inches this way and maybe 12 inches out. I don't know, but these are the parameters. Oh, and just to make sure, just so y'all can see this, let's do this. Let's do M+ so that I can just delete them later. And go 100 feet, bam. Oh, maybe it wasn't 100 feet. Let's just pull them into the garage. Yeah, there we go. So, yeah. Whoops. Hope y'all don't get seasick. I'm using 3D mouse so that I have what is it? It's like front, back, left, right, up, down, all simultaneously. And sometimes it works really good. I don't know if you can see this. There's a little blue kernel of bits right there. And that's what I end up spinning around. And it pops up randomly in about the center of where I'm at. So if I start spinning, it doesn't get stupid. But I still have to learn to drive this thing better. But I like this. It's a cool little garage. 24 by 24. If it was me, I would make it, yeah, 24 is fine for the width, but it would be nicer if it was just deep enough that a full-size truck could fit over on that side. So that would be 24, 5, 6, 7. So let's say 28 feet deep, 24 feet wide. Oh, and check this out. This is part of Medic, the BIM foundation software. Look at that. Turn on the X-ray, and you can spec all these parts. Anchor bolts, hold down straps, number 4 rebar on a 2 foot by 2 foot grid, continuous around the perimeter. I made this perimeter massive. It's way bigger than it would normally be. I think it would probably be like 12 inches, but I made it 24 just because I was just messing around. Oh, and also, if you look, they always do thickened slab when you drive in so that you don't break it. So I added these 2 pieces of rebar, and I made this pretty heavy duty. And that's when you see it on the plans, thickened slab through doorway. That's what they're talking about. They don't want a 4-inch little slab coming all the way out to the outside, because that first little bounce or that first little lunge from your vehicle tends to really abuse that bit of concrete. So, but X-ray is just unreal. You can see all the joists. And everything's stack framed. So if you didn't know what stack frame means, it allows the least amount of deflection, because everything is compressing right on top of the next thing. And in framing, you can do it any way you want. If you want to not stack frame and you want to have joists over here and rafters over here and all that, you can do that. It doesn't look very professional. And if your other trades are trying to bring like a plumbing pipe up and immediately they drill into a joist because you've got a joist in between your stud bays, that becomes a problem, especially in apartments and hotels. But if you are a professional and you read the plans, and always start from the roof, always look at the roof, figure out what the roof is doing, look at where your loads are going to be. I'm going to have loads here. This beam is going to support this ridge and that ridge in the middle. And the rest of these, the rafters are pushing out on the walls. And so at the outside, this will all get tied together, but these rafters are going to want to push. So what's nice is we've got ridge support here and here. It's not very long, so I don't think there's going to be a problem. You could go vaulted or cathedral or whatever. But if you came down half the distance and then ran joists across instead of up high like this, like we called these wind ties because they were right at the bottom of the ridge and they just held the rafters to the ridge. But if you came down half the distance, you'd have like a 10-foot ceiling and it would be flat. You could do a lot of neat stuff with it, and it would help hold the rafters from pushing out on the walls, which the more I look at this, the more this isn't going anywhere. This is a very solid little design. So, and what's nice is you get all this space under the 12 and 12s on both versions, the Leon and the True Valley. So there you go. Let me know what you think. I'm sure there's like 10 different ways to frame this. So I'd like to learn from some of you guys who would do it different, or if you think this is a cool way. And if you want this file, I will include a link to this file so you can download it and mess with it any way you want. So there you go. All right. Rambled enough. Thanks for watching.